Hello everyone, welcome to the video lecture series of Grade 10 Physics Light Lesson. Today we will be discussing the following topics: laws of reflection and spherical mirrors. In the previous videos, I discussed what is light, reflection of light, and the terms incident ray, normal, and reflected ray. Please watch the same to get a better understanding of this lesson. The video link I have put it in the description box. So let us take the first topic, laws of reflection. To understand this laws of reflection, you need to know what is incident ray, what is normal, and what is reflected ray. Consider this as a plane mirror. And the light which is incident on the surface of the plane mirror is called incident ray. And you know what is happening when a light is incident on the plane mirror? It is reflected back. So this is reflected ray. And the line drawn perpendicular to the surface of the mirror, it is normal. Now when you look at this diagram, if you're trying to measure the angle of incidence means the angle between the normal and the incident ray. So this is angle of incidence, angle I, that is angle of incidence. It will be equal to the angle of reflection. Angle of reflection, I am writing angle R. So angle R is the angle of reflection. Which means angle I is equal to angle R. Which means if angle I is 25 degree, then angle R also will be 25 degree. If it is 30 degree, then angle R also will be 30 degree. So this is the first law of reflection. Angle I is 25 degree, then angle of reflection also will be 25 degree. The angle of incidence is equal to angle of reflection. This is the first law of reflection. And when you look at this diagram again, the incident ray and the normal to the point of incidence and then the reflected ray, these three are all lie in same plane. The incident ray, normal to the point of incidence, and the reflected ray all lie in same plane. This is the second law of laws of reflection. Okay, so far we discussed two terms, the first law of reflection and the second law of reflection. What is first law of reflection? It states that the angle of incidence is equal to angle of reflection. And the second one is the incident ray, the normal to the point of incidence, and the reflected ray, all three lie in the same plane. These are the two laws of reflection. These are the two laws of reflection. Angle of incidence is equal to angle of reflection. Second one, the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. And this law is applicable to plane mirror as well as spherical mirrors. What is a spherical mirror? Spherical mirrors are mirrors in which their reflecting surface is curved, either inward or outward. So their reflecting surface is a curve. Either it can be curved inward or it can be curved outward. Now consider this spoon. In this spoon, the inside portion, it is curved inward. So this can be considered as a concave mirror. So what is a concave mirror? Concave mirrors are usually the reflecting surface is curved inward. But when you look at the outside portion of the spoon, it is curved outward. That can be considered as a convex mirror. Now you know the difference between a concave mirror and a convex mirror. In a concave mirror, the reflecting surface is curved inward, but in the case of a convex mirror, the reflecting surface is curved outward. These are the two types of spherical mirror which we are going to discuss today: concave mirror and a convex mirror. So let me try to draw a concave mirror now. So this can be a concave mirror. So this is the curved inward portion. This is a reflecting surface. This is a reflecting surface. Reflecting surface. I'm going to shade the backside portion. The shaded portion, this backside shaded portion is the non-reflecting surface. Let me draw a convex mirror now. In convex mirror, the reflecting surface is curved outward. This is convex mirror. This is the reflecting surface, and it is curved outward. Reflecting surface. The shaded portion is the non-reflecting portion or non-reflecting side. Now, either it is concave mirror or a convex mirror, the central portion, the center of the mirror is called pole. I am giving a letter P. P is the pole of the mirror. Pole of the mirror. The center of the reflecting surface of a spherical mirror is a point. So this point is called the pole of the mirror. Now, whether it is a concave mirror or convex mirror, the reflecting surface in both cases actually forms part of a sphere. If you are considering this sphere as a concave mirror, this is a reflecting side, okay, because it is curved inward. and the back side. This is the non-reflecting side. Non-reflecting side. The dotted portion is the reflecting side. Reflecting side. So this can be a concave mirror, and this actually forms part of a sphere. And the sphere has a center. This point is called the center of curvature of the spherical mirror. So it can given a name C. So C is the center of curvature. What's the meaning of center of curvature? Center of curvature is the center of the sphere. Center of curvature. And in the case of a convex mirror, so this is a convex mirror. So it means that the reflecting part is curved outward. So this is the reflecting part. The dotted portion is the reflecting part, reflecting side. Okay, and inside this is non-reflecting. Non-reflecting. Now, this convex mirror also has a center portion. See again. So it is the center of curvature of convex mirror. We need to understand that in the case of convex mirror, the center of curvature lies in front of the reflecting side. But in the case of convex mirror, the center of curvature lies behind the reflecting side. Now, the radius of the sphere, I am giving the name R. R is the radius of the sphere. We can call it as radius of curvature. Radius of curvature. The radius of the sphere of which the reflecting surface of a spherical mirror forms a part is called the radius of curvature of the mirror, and it is represented by the letter R. Now in the case of convex mirror, this is the radius of curvature R. And you just imagine a line is passing through the center of curvature C and through the center of the reflecting part, that is pole P. Okay, an imaginary line is passing through the center of curvature and the pole. This imaginary line is called principal axis. Principal axis. So in the case of convex mirror also, you can imagine the same concept, an imaginary line passing through the center of curvature and the pole. And this is the pole. Pole is the center of the reflecting surface. So this imaginary line is called principal axis. Now let us look at an activity from the textbook. Okay, this is activity 10.2. For this activity, the source of light is sun, and you need a concave mirror and a sheet of paper. I am drawing a concave mirror over here. This is the non-reflecting side of the mirror. Concave mirror and a sheet of paper. Okay, now You need to keep the concave mirror in such a manner that the reflecting side is facing the sun. Okay, so the rays of light from the sun is incident or striking on the surface of the mirror, and after reflection, the sun rays, you need to focus on the paper, which means that you need to adjust this paper, or you need to move the paper back and forth, so that until you will get a spot of light over here. So when you adjust the sheet of paper, you will get a sharp, bright spot of light. And this sharp, bright spot of light is actually the image of the sun. And this is the focus, principal focus of the concave mirror. Now, you need to hold the mirror and the paper in the same position for a few minutes. Okay? After some time, the paper begins to burn, producing smoke. Eventually, it may even catch fire. Why does it burn? The light from the sun is converged at a point as a sharp, bright spot by the mirror. In fact, this spot of light is the image of the sun on the sheet of paper. So, this point is the focus of the concave mirror. The heat produced due to the concentration of light ignites the paper. So, the distance of this image from the position of the mirror gives you the approximate value of the focal length. So, this distance is called the focal length of the concave mirror. Now let us try to explain this activity in terms of a ray diagram. Ray diagram is easy to explain this kind of diagrams in terms of 2-3 rays. So basically you need a concave mirror or the type of mirror which we are using in activity, and the source of light, and where do we get the image. So these are the three things which we are actually focusing on the ray diagram. So in this case you already know the source of light is sun, and it is far away from the concave mirror. So we are using the word infinity. Sun is your object now, and it is at infinite distance, or we say object is at infinity, and the type of mirror used is concave mirror, and you are getting an image on the sheet of paper. Okay, so let me try to draw a ray diagram for this activity. So as I told before, we need a concave mirror, and this dotted portion is the, I'm putting some dots over here, and this is the reflecting side, and back side of this mirror, this is the non-reflecting part. It is the back side of the mirror. So this is a concave mirror because it is curved inward. Now what is center of the mirror is called? Center of the mirror is called P. Okay, P is the pole of the mirror, and you already know we can draw an imaginary line from the center of curvature through the pole. This imaginary line is called principal axis. Okay, now I am going to place the object at an infinite distance. So this straight line represents the object. Okay, I'm giving the name AB. Now the object is at infinite distance. Object at infinity, which means object is placed far away from the mirror. That is the meaning. I'm going to draw 2-3 rays starting from the object, and it is reaching on the or falling on the or strikes on the concave mirror. So this is our incident rays. Okay, and it is falling on the surface of the mirror or reflecting side of the mirror. Now I'm drawing one more incident ray. Falling on the surface of the reflecting surface of the mirror. Now you already know when light rays falling on the concave mirror, it undergo reflection. Any kind of mirror, it undergo reflection. This is the point of incidence. Here this is the point of incidence. When it strikes on the mirror, it undergo reflection. This one is the reflected ray. Now from this side I'm drawing another ray, reflected. I will draw that ray one more time because it is little curved. Okay, yeah. This is the reflected ray. So after reflection, the rays of lights meets at a point, okay, or intersecting at a point in front of the mirror. So this point is called the principal focus of the concave mirror. So F is the principal focus of the concave mirror. And the distance between the principal focus and the pole of the mirror, distance between F and P, is called the focal length, small f, focal length of the concave mirror. Okay, now we explain two terms now. After reflection, the light rays are meeting at a point on the principal axis. So that is called the principal focus of the concave mirror, and the distance between the principal focus and the pole is called the focal length, small f. The same ray diagram you can explain for convex mirror also. So let us try to draw a convex mirror now. Now this is the diagram for a convex mirror. In the case of convex mirror, the reflecting surface is actually bulged outward. Okay, so the dotted line, this dotted line represents this side represents the reflecting surface, and this one, this is the non-reflecting part of the convex mirror. Now P is the center of the mirror, and that is the pole. P is the pole of the mirror, and in the case of convex mirror, the center of curvature is actually on the back side of the mirror. So this is the center of curvature C, and the imaginary line passing through the center of curvature is called the principal axis. So C is the center of curvature, and this line represents the principal axis. Now you need to place the object at an infinite distance, like in the previous case. So AB is the object placed at infinite distance. So object at infinity. Now as usual, we are going to draw 2-3 rays coming from the object. This is first ray I am drawing, which is falling on the surface of the mirror. One more ray I am drawing over here. Another ray of light strikes or incident or falling on the surface of the mirror, and after falling on the surface of the mirror, it reflects back. So reflected ray. This is also reflecting back, and these reflected rays actually appear to come from a point on the principal axis. Okay, so when I extend this ray, this reflected ray, it is usually appear to come from a point on the principal axis. Okay, so this reflected ray, I'm just extending on this line. It meets over here on the principal axis. Similarly, the other reflected ray, I'm just drawing, and both these reflected rays appear to come from a point on this principal axis, and this point we say the principal focus F of the convex mirror. So F is the principal focus of the convex mirror. So you need to remember one thing in your mind, that while drawing a convex mirror, the principal focus is formed on the back side of the mirror. Okay, and the light rays actually, after reflection, it is coming back to the original position. You need to extrapolate, or you need to extend these lines to the other side, back side of the principal axis, and these reflected rays both meet at the point on a principal axis, and this point is called the principal focus of the convex mirror, and it is coming on the back side or behind the mirror. And what is the distance between P and F? That's called small f. What is small f? Focal length. Focal length of the convex mirror. And it is represented by small letter f. Usually the reflecting surface of a spherical mirror is by and large spherical. The surface then has a circular outline. The diameter of the reflecting surface of a spherical mirror is called its aperture. So we are coming to know one more term, aperture. Aperture is the diameter of the reflecting surface of the spherical mirror. This is the reflecting surface. Okay, the diameter of the reflecting surface is called aperture. For spherical mirrors of small apertures, the radius of curvature is found to be equal to twice of the focal length. So we can write a formula for this one. So R is equal to 2f, which means that the radius of curvature is twice the focal length of the mirror.